Hello and welcome to another video from Flash Jazz Cat, and a very happy new year to you all, and I hope 2023 is treating you well so far. Now in this video I'm going to try and get VGA video out of the Atari 800, in which I fitted VBXE a few weeks back. I know this is the third video in a row dealing with this, but it will be the last one and I will move on to other things afterwards, and I found it a little bit difficult to get back into the swing of things after the Christmas break anyway, so this is a sensible way, I think, to get back into it. But before we do that, since this is again covering the Video Board XE, which is available in the community area of PCBWay, and I know a few people have ordered boards from there since I made the earlier videos, and there was a routing error on this board which Candle has corrected now. But yes, this is available from PCBWay, which leads us nicely into the message, the first message of 2023 from this video's sponsor.
How's that PCB design going? You know, that PCB you were talking about 3 years ago? Been working on that for quite some time. Still routing those traces? How's that ground plane coming along? If you're stuck in a rut with your PCB designs, consider PCB prototyping the easy way with PCBWay. You can get an instant quote and a fast turnaround in as little as 24 hours from a company with more than a decade of experience in producing printed circuit boards for customers with demanding requirements. As well as a PCB prototyping and assembly, PCBWay can also help with CNC machining and even 3D printing. So don't be like Brian and procrastinate for 3 years. Visit PCBWay today.
Alright, so back to the video. So as I said, yes, there's been a correction here, and this has enabled the fc.com VBXE Core Manager to work. Now why is this important? Well, it's important because the VBXE carrier board here is fixed up out of the box to output VGA video, as well as the 15 kHz RGB SCART type video that you normally get out of this thing. Candle wanted me to demonstrate this in the earlier videos, but I couldn't have done so anyway because it's taken this long to figure out. Candle figured out actually that he'd missed this trace off the board, and that was what was preventing the fc.com core management tool from actually recognizing the hardware. So with this fixed, everything works. Absolutely everything works now. Now the reason we need to get into the core management tool is that when we wire this up for VGA video, we need to use the VGA core for VBXE. Now I thought this was deprecated, but it's become a thing again apparently. Candle reckons it's going to be quite handy for people who can't get hold of 15 kHz monitors and stuff like that, who want to install this and get VGA out of the machine, and hopefully that'll be compatible with any old monitor that is capable of displaying a VGA signal. So yet again I've had to take this machine apart. Oh, since the previous video as well, I did fit the RGB connector here. It hasn't lined up perfectly, but I think I made a decent job of it. I did put some pictures of it on Facebook and it's turned out okay. It was very, very difficult to figure out how to get this hole to look halfway decent, but it does work anyway, and the plug fits in it and it all looks nice. And I've made an interconnect thing here underneath the connector, so the connector is mounted to the PCB just like the other one, so it looks reasonably stock. Obviously it replaces the channel switch, so obviously I needed this to be to have connectors on the end so I can actually take the machine apart again. So this connects to these two wires here, which are coming out, well, they will when the shield's back on. There's a little hole, so I have to thread these two connectors through the hole that I made in the side of the Faraday cage. But I mean, it's fiddly to put it back together, but it does work. Now this is carries the stereo audio. There isn't any stereo in this machine, but it is left and right audio. So that's connected to mono audio out, which we pick off somewhere down here. I can't remember where. Anyway, so we get audio anyway, and the other wire here is composite sync. Now, and this obviously, this is the 5-way header that just goes straight to the VBXE. That's got RGB control and ground, and this is audio and composite sync. Now the composite sync wire here, I didn't really want to take this apart again because it is a nightmare to thread all these wires through. So what I've done, so the composite sync wire did oh well, there's the audio wire, that one there. I hope I've got the right one. Yes, I have. So this is the audio wire, so that's coming. I've just taken that off the point where audio actually comes out of the motherboard and goes to the other board. And this is the composite sync wire here. So I've snipped this. This used to just be continuous wire going down here, which I think is just composite video actually I've used. So I've cut that in half and I've put a connector on the middle now. Why have I done that? Well, to make things a little bit easier when I want to switch to the VBXE VGA composite sync, which I think is pin 1. Was it pin 1? Yes, it will be. So that's this one here. So it says VGA sync down here. Let's get closer. Right, so here we've got VGA CSYNC. So that's what we're going to take. We're going to take that signal and we're going to send it round the plastic casing here, and we're going to plug it in. Here we're going to connect it to this male connector that I've just put on here. So that will now feed into the composite sync, or what was previously the composite sync wire, that goes to the video jack. Right, so what we also need to do, apparently, according to Candle, is inject a VGA compatible 31 kilohertz master clock signal into the VBXE instead of the oscillator source frequency coming from either of these crystals. Now, how do we do that without taking the crystals off? Easy, because if we look here on the board, we have a crystal which is set up at exactly the right frequency for the job, and the output of that crystal comes from VGA VBXE clock down in the bottom corner here. So what we're basically going to do, I'm not sure which pin it's going to be. I think it's going to be, again, it's going to be pin 1. So what I think what we're going to do is put that jumper on there, and we're going to connect that to the middle pin. If we have a look at the VBXE board itself, of course, if you've got one of these boards, you'll have noticed probably that there's a jumper, which I've got here, and I've taken it off, a jumper like this. There was a jumper over one or the other pairs of pins here, depending on whether you wanted the NTSC or the PAL clock frequency. So that selects one of the two crystals here, you see. And I think that, well, I'm assuming it must be, logically, that that pin there pertains to that crystal there. That pin at the front of the edge of the board pertains to the other one. And the centre pin, because you're going to move the jumper between position 1 and 2, the centre pin is the input. So what we can do here is we can connect this wire to that clock input, and then the crystal on the VBXE adapter board is providing the signal here. So hopefully, if I've got the cable length right, that will push down. Oh God. Please go on, I don't like making cables and wires and crimping stuff. Yeah, that looks like it's going to fit. So then we can just push this down here, and that should be VBXE with a new clock input coming from the board, coming from the crystal here. So that's that part done. Apparently we just take VGA CSYNC, feed that into the CSYNC wire that I've just put a connector on, change the VBXE core with the fc.com tool, and then it'll work. Right, so let's put this thing back together. Now the first thing I'm going to check, I don't care yet about the VBXE signal. What I want is a working machine on the legacy video output, because we can't do anything until we've got that. So all I care about at the moment is getting the thing to power up with legacy video, and then we can run the fc.com program. Right, a bit fiddly, but there we go. I can just run this. So this is the sync signal, so we can run this to this cable here, like so, and see if we get a working machine. What we got. We got nothing. Right, maybe I've got the... Maybe I've got this in the wrong position. Alright, try again. Come on, come on. Alright, we've got nothing. Okay, so I didn't get a picture, and then I got a rolling picture. I'll show you what the rolling picture is like. I'll just turn this way a little bit so you can see. I've just been chatting to Candle on WhatsApp there actually. He's sitting in the cinema and he was kind enough to respond. And I had actually forgotten a jumper. The jumper on the adapter board, I'll flash a picture up so you can see what I'm talking about. There's a jumper on the board underneath the VBXE. Now that needs to be shorted in the sync position. So I did that. That didn't actually change the situation, however. Now the crystal on the motherboard that was disconnected, because we removed the transistor when we were in standard RGB mode, the wire that goes from that spot on the motherboard to the adapter board, we've moved that from the RGB sys clock position to the VGA sys clock position. We've got the signal from the crystal on the VBXE adapter board going to the VBXE, so that's correct. We've got that jumper in the CSYNC position, that's correct. So we should, using legacy video, we should really get a picture. I'll show you what we get. It comes and goes. It's very strange indeed. So if I stick the probe on here and show you the signal we're getting here, if I just adjust the size and position a little bit. Sorry about the angle, that's as far as this camera will go. So there's the clock on the motherboard. Yeah, we've got a picture, as you can see in the corner here, we've got a kind of a picture. It comes and goes, it's a real mess. So look at them, we've got all sorts of strange stuff going on here. The signal doesn't look too good now. It's sort of jumping all over the place. Something's seriously wrong. So what I decided to do was measure the system clock output right on the adapter board instead. And all of a sudden when I do that, it's not perfect. So when I've got the probe on the pin on the adapter board, the source of the system clock, I get this, and on the scope you can see that signal, which looks kind of strange still. That's better. That doesn't look too bad. Right, try that again. I'll put the probe on there. Probe on. There we go, we've got something. And then when I take the probe off, we lose the picture. This is weird. I haven't even got the ground strap connected to the scope. Is this probe acting as a capacitor? I wonder. Because I did try this off camera. It is shimmery at the moment, it looks worse. But it looked pretty solid the last time I tried it. Now that I've got the camera on, of course, it's decided to act up again. So there's something strange going on here. I'm going to try replacing the little wire that goes from this pin to the VBXE board, just in case. There we go, it's gone totally rock solid now with the probe on. Absolutely perfect. Everything working a treat. And if I take the probe away, it falls to pieces. Right, so a few hours have elapsed now, and I did get a response from Candle to the last question I asked him regarding does the scope probe act as a capacitor to ground? And he said yes, it does. So he suggested I try a capacitor to ground between pins 1 and 2 of P6 there, which is that's exactly where I had the probe. I'd slid the connector up there and I'd stuck the probe on pin 1 there, and that fixed the problem, or seemed to anyway. And I had a look on the scope, and it is 20 picofarads of capacitance on the probe. So I pulled out a 15 picofarad cap and I soldered it between those two pins. I tried a few various values actually before he suggested I check the scope. Sensible thing to do. And I got no signal at all even with such a tiny capacitance, I just got no signal at all and the machine was dead. So fortunately what Sebastian suggested is that I check the soldering on U2, that IC there. But everything looked okay, so all I did here is I just smothered everything in flux. That's the stuff I use, so I just smothered those chips and the adjacent decoupling caps in flux, and I just went over them with a soldering iron. Cleaned it all up with a cotton bud and some IPA, and now it works. So how about that? But this gave, while I've got before I actually show you it working, and then we can move on to phase 2, which is actually getting VGA video out of the thing, or trying to. I'll take this off because I wanted to show you that jumper that I mentioned earlier on. So it's that one there. I know it can be a bit confusing, there's so many steps here. I'm going to have to sort of summarise them. But it needs to be written down, really. It needs to be written down. Because it's too complicated to follow. I've been sort of figuring this out piecemeal. I ended up taking a picture of this board and just putting it in Microsoft Paint and drawing arrows between A and B and send it to Sebastian to say, does that go there and that goes there? And he said yes. So I knew I had the connections right. So the two important ones anyway are pin 1 of P6 to the centre pin here. I'll just move this up so you can see it. The centre pin there. So that's essentially the clock input, as I mentioned before, because you've got the two crystal outputs here, and depending on where the jumper is, that's normally fed into the centre pin. So we're taking that signal from the onboard crystal here and feeding it straight into there. And the other one is this one here, which I'd forgotten to do initially. I didn't have a jumper on here at all before. I don't know if it matters. It worked fine before in RGB mode anyway, but I think the jumper's supposed to be in the ready position in normal operation. But here we have to have this jump up GP1 jump it for VGA CSYNC. So we'll put this back on now, and I'll put it back in the board and hope to God that it still works. It worked a minute ago, so hopefully it still works. So we'll put it back. Right, turn it on. There we go. Now the reason it's come up with profile reset, you God damn it, won't be. Oh dear. Uh-oh. Uh-oh. Alright, so after reworking, the soldering didn't help, and the 15 picofarad cap that I put to ground from the clock source didn't help. Fortunately, after the film finished that Candle was watching at the cinema, he had one final suggestion, and that was to remove both of the capacitors on the VBXE board itself next to the crystals. Now I thought that since we're injecting an external clock source into the VBXE using that centre pin, and it's not connected to either of the crystal outputs, because of course there's two crystals on the VBXE, I thought that because we'd removed that jumper, it was in neither of the normal positions, that the crystals were completely isolated and the capacitors were completely isolated, but apparently not. They're only isolated on one side, and I'll show you what I mean. So having done some resoldering work on the adapter board and finding that didn't do anything, it appeared to work, but then it didn't work.
Sounds good, doesn't work.
Candle had one final suggestion, and that was to remove the capacitors on the crystal output on the VBXE board itself. Now I thought that when we remove the jumper, which normally either connects the NTSC clock output crystal output here, or the PAL crystal output here, to this centre pin, which is the clock input, I thought when that jumper was removed we completely isolated these capacitors, but Candle says only on one side. I'm showing you on a different VBXE board here, and if we measure between the centre pin and this side of C24, sure enough we've got a capacitor to ground on the actual input. I did take the other one off as well. I don't think I needed to do that. I think it was C24 that we needed to take off. I took off both because I wasn't sure at the time, but now I test them. It looks like C24 serves for both possible inputs. So rather than having a capacitor to ground on both of these crystal outputs, he's chosen to put the capacitor to ground on the input, and this of course smooths out rough edges in the clock signal. But that's a bit of a problem in this case. If the cap to ground had been on each of the crystal outputs, then we would have had no problem at all, because when we remove that jumper, those two caps, as it would have been completely isolated, but it isn't, because the cap is on the input pin. So anyway, I took both of them off. I only needed to take one of them off, but I took C24 anyway, removed, and that has allowed it to work. So what that was actually doing to the external clock source, this capacitor, which is a 22 picofarad, I believe, was actually flattening it out too much, and that's why we weren't getting a proper system clock, and that's why the video display was falling apart. So having removed that, well, I'll show you what the result is. Now, another thing I've done here while I was off camera, because the external clock is NTSC, when it's run through the clock divider, it's basically driving the motherboard at NTSC frequency. I've replaced the GTIA and the Antic chip with NTSC parts, and because we've got an SCC board in here, SCCC, Supercolor CPU card, all I had to do was do that and then swap the jumper on the SCCC board from PAL to NTSC, and then we've now got an NTSC 800. I think this is going to work best, the VGA, when we get to that point. It's going to work best at 60 Hertz. So this now, for the purposes of this demonstration, this 800 is now NTSC. So, do we now get stable legacy video? So let's turn it on and have a look. And yes, we do. So now we get stable S-video, stable system. I can go in here, it's not shimmering, it's not breaking up. As you can see, it's now got the NTSC aspect ratio because I changed the chipset. And all of that trouble was caused by that capacitor C24, which is unfortunate. It means you've got to do a little tiny little modification on the VGA, the VBXE board. But I don't think, because I'll be undoing this modification when I've finished demonstrating it, because I use SCART with this TV. The quality's excellent, so I've got no particular need for VGA, but I don't think it's going to be especially important even if that cap's missing when you revert to using the onboard crystals on the board. We'll see anyway. I'll certainly put the other crystal back. Which one was it? C25 I'll put back. It doesn't look to me like that was anything to do with the problem at all. So we've got stable stock video. So the next thing we want to do is get VGA. Right, so in order to get VGA video out of the machine, we're going to need a cable, obviously. So this is the cable that I've made up, and this is using the DIN 13 on one end, which is the standard, I call it the standard anyway, 1088 XEL if you like, pin out. So we've got red, green, blue, composite sync and stereo audio on here. We don't need the RGB select that we use with SCART. So on the other end, of course, I've got a standard DB15 connector, male VGA connector, and I've just wired the RGB lines up to here. I've actually put the composite sync on H-Sync and V-Sync pins on this connector. I figured this will give us the best chance of success. And for audio, although the audio on the 800 isn't stereo, this DIN has provision for stereo audio anyway. So I've used a 3.5 inch stereo connector, because that's what this TV expects for audio with VGA or DVI. So that's the cable, and the next thing we need to do is flash the VGA core for VBXE. Now there's two VGA cores for VBXE, I'll show you in fact. So we've got over on SIOT PC, we've got the core distribution ATR that you can find on Litharek website. Now I couldn't figure out from these cryptic descriptions here what the hell was the VGA core. So I actually went for an older one on pigwa.net I'll link it under the video, but actually Candle has since sent me the cores over WhatsApp. I think they're identical anyway, so I think I had the right files to start with. So if we run the FC tool from here, I've actually put the cores in a different on a different drive. Now the funny thing here, that this is what I can't, there's one thing that really isn't working correctly, is that these banks, there's actually, well there were 5 used banks on here. The first one's the standard FX126 core, version 1.26. Various other cores here like GTI, only emulation and stuff. There was 5 slots out of 12 were used. Now since I've done this modification to the system clock, this tool can't read the names, the descriptions in the original 5 occupied slots, and indeed in the first one here it says the rest are empty. They're not. And the first one here, it says that the name is a clear screen character, which is completely wrong. So I don't know why that has suddenly started to happen. I'm running through this again, in fact, because as you can probably deduce, I have already done this previously off camera, but I'm going to run through what you need to do. The odd thing is here that when I go through the next set of banks, so we had 1 through 5 were populated before we started to do this work. Now we've done this work, they're showing up as empty, although they're not. It thinks 3 are used, but when I've flashed the 2 VGA capable cores in slots 7 and 8, those descriptions get updated on the flash ROM and they stay there. So what on earth is going on with this? I really don't know. So there's something funny going on there, and I was a bit reticent about doing the flash in case it screwed up the other cores and I ended up with a bricked VBXE or something. But fortunately that didn't happen. So what I've elected to do anyway, if we ignore that problem for now, is I flashed the 14 MHz core to slot 7 and the 28 MHz core to slot 8. Now the difference between these 2 cores is that the 14 MHz VGA core, this gives you basic VGA capability and little else. So you won't get 80 column text, blitter, all that kind of stuff. It's just bare bones, well, as you can see, GTIE emulation, so it's just GTIE video over VGA. Now the advantage of this one is that of course it uses the onboard crystals on the VBXE board itself that are already there, so you wouldn't have to do that modification where you remove C24, and you wouldn't have to have the external clock. But it makes sense to use the 28 MHz core here because we've already got the external crystal on the board. Caveat there, if you want it to be a PAL system, you're going to have to change that crystal. But nevertheless, we're going to go with the 28 MHz core. So for the 14 MHz core, you don't really need to do much of anything at all. You're still going to use the onboard crystal, so you'll have the jumper in the usual position for NTSC or PAL. And composite sync, still be used for synchronization, and that's pretty much it. So you can just flash that, get VGA out. But we're going to go for the 28 MHz core here, and this is the one I've set as the boot bank. And when I talk about the boot bank, the thing is that the FPGA on the VBXE board, it isn't programmed with anything persistently at all. It's just a field programmable gate array, and it gets programmed when you turn the power on. So the AVR chip on the VBXE reads whichever is the boot block from the flash ROM on the board, loads it into the FPGA very, very quickly, and that's how the FPGA gets programmed with the core. So we've got the core set as the boot bank, so if we now plug in our cable, we should get some VGA video. Now, for the sake of full disclosure here, when we finally reached this point of getting the correct core flash and everything yesterday, I think that was Sunday, was it? I lose track of the days now, but yeah, when we did finally get everything flashed and prepared, one thing that hampered me for about an hour when I was trying to figure out why I was getting no VGA picture is that I'd completely forgot to connect the RGB harness to the VBXE. So this is a reconstruction of what the situation was like there, so I'm going to reconnect this now before we go any further. Okay, so now I'll boot the machine, and if we switch over to the VGA channel on here, VGA input on the monitor, we should get a picture. And we do. So great. So that is VGA video. Now I'll show you what the quality is like, because it's not fantastic. It's not bad. So here's a little look at the actual video quality that you're going to get here. This is going to vary from monitor to monitor, I'm going to say. I'm pretty sure. This monitor is from around about 2008. So it was one of the later monitors that actually had S-video inputs and that kind of thing. So it's a really, really good monitor. It's got DVI and all sorts of stuff, component, you name it. But this was one before they started to drop S-video, and then they started to drop second SCART connectors, which were wired up for S-video. So really, you're lucky to get any kind of YC video input at all on a modern LCD TV or monitor. You usually just get composite. But this was one of the last ones, and in all respects, in all scenarios, including things like ST video, Amiga, ST high-res, monochrome video, which uses the VGA input, of course, and it drives the RGB all at the same level. It's really, really good, and of course it does the auto sync thing, and it looks really, really nice. I've manually tweaked this picture just to get the screen centered and stuff, because the auto scan, it pushed the screen right up into the top left corner, and I wasn't too happy with the phase that it had selected, so I've tweaked it a bit just to get things looking reasonably even. It's got a bit of fringing, vertical fringing on the edges of the letters and stuff like that. I can't seem to dial that out, but I mean, it's an image, it's nice and sharp, there's no jail bars down it to speak of, it's nicely saturated, and of course the advantage is here that if you haven't got a SCART capable display, you can get video out of the machine, really good quality video. And moreover, you can get all your fancy features that VBXE provides, including 80-column text, glitter, all that good stuff, lots and lots of colours. So that's what the quality's like. It's on this particular set, I prefer SCART, but your mileage may vary. It's going to depend on the analog circuitry, or the analog to digital circuitry in the TV. Now, another thing that you might notice here is that we've got NTSC colour out of the VBXE here on the VBXE output, and the reason for that is that I've got the new firmware on here. Obviously this is an Incognito with the version 2 JED flash to it, and this is the pre-release firmware that I'm going to release very, very shortly. I've been promising to release this for about 3 weeks now. It was supposed to be out at Christmas. It didn't happen, and someone was asking about it the other day, and I just haven't had time. It's done. I just haven't had time to upload it yet properly to the website. And it was good that I procrastinated for a bit, actually, because I found a couple of bugs that I've fixed along the way. So it's never a good idea to hurry these things. But anyway, it's got the VBXE plugin, VX, and VX is the one with the dynamically loaded NTSC palette. Now if I turn this NTSC palette off, save the settings, and then power cycle the machine, I'll show you what the difference is. So this is the VBXE display without the soft loaded NTSC palette, and as you can see, it's got the, I think it's the Lao or whatever it's called palette, and it's totally PAL. It looks like a PAL Atari display. So since this is most useful, this VGA modification for the NTSC user base, commonly it's going to be used by NTSC people. So in this situation, you're more than likely going to want to enable NTSC palette, and then your VGA VBXE video will look proper, with the proper colours that you'd expect to see on an NTSC machine. So we've got working VGA video, let's just have a little look at some VBXE things that we can now do. I've installed, because I was reading about it on the forum earlier on, a couple of questions about it, the Sparta Commander. So let's have a look at the 80 column Sparta Commander display. So if I CD into the Sparta Commander folder and then run SC, press space when done. Oh, that's ironic. That was just what was being discussed on the forum actually. Okay, so I haven't used this program very much, but I mean it is really, really good. You can view files and such like. I don't know why this isn't using the 80 column display. I haven't quite figured that out yet. Q to quit, space when done. So as you can see, you've got hardware 80 column text. I'll give you a close-up of this anyway so you can judge the quality for yourself. Alright, so this is about as sharp as I can get it, unfortunately, but as you can see here, 80 column text. You've got that fringing again on the verticals. As I say, on this particular set I get better looking 80 column VBXE text over SCART, and you can see some problems down here which I've tried to dial out with the settings on the screen. You've got some slightly uneven vertical lines, probably just a characteristic of the monitor. Well, why not? I'll try and auto configure the screen just to see if it has an easier time with the 80 column text than it did with the 40 column text. Let's give it a try. There we go, screen. So auto config, let's do it. And it'll put the display back in the top left corner as well, which is annoying. Ah, there it is. It hasn't really improved matters. I think it looks worse now. So I'm gonna move the display again back to where it's supposed to be. So that's about as good as it's going to get on this set, I think, unfortunately. Size, I'm not going to change. Phase, I think I had that set to about 20. Yeah, it's about as good as I'm going to get it on there. So we can try a few other things just to demonstrate some standard video stuff as well. Just pick some random stuff. Boogie Nights. The colours are going to look a bit strange because it's NTSC, but nevertheless. And the music's playing faster, of course, because we're running at 60 frames a second. So that's a bit weird. I'm trying to think of something that uses PAL color blending. E-Type, does that use it? I can't remember. I think it does. No, I don't think we've got PAL color blending here, so that's something to bear in mind. Right, something else we can have a look at here to demonstrate VBXE capabilities here. Or Stephen's little demos that he put out before, which I like to run. Now, if we CD into 1024 colours, something worth pointing out here, this one doesn't display properly because one thing that this 28 MHz VBXE core for VGA does lack is one of the palettes, which was sacrificed for the line buffer, apparently. So you've got 3 palettes on this core rather than 4. Now I'll show you what the effect of that is here. So we're missing a palette, so this is the result here, that we get a corrupted image here. We're missing an entire lot of colour, but never mind. If we CD back up here and we CD into scrollers, scrollers of 1L, there we go. Right, purple. Okay, there you go. There's the purple demo. It looks excellent. Really, really good. Quit out of that, and I'll quickly show you the other one. So really powerful machine, I think, short of actually having a Pokémax or a simple stereo 4 in it. I don't think you could get much more of a powerful 800 at the moment. Well, don't anybody mention stick a repeaters in it, for God's sake. I think we've pushed the stability of this machine quite far enough, for the time being anyway. So there you go. So I hope you found that one interesting. As I say, I'm trying to wrap this one up. I don't want this to get too long, but this is the conclusion of what has become a 3-part VBXE in an 800 video, and it's culminated. Here we are with VGA video coming straight out of the analog video jack. Unless there's anything else exciting that I need to demonstrate in a future video or a short video or something. I'll be taking this modification back out of the machine because I want to use this one with VBXE just with a standard 15 kHz SCART output. Works fine for me, does everything I want it to do. So there you are. So thank you very much for watching. I do hope you found that one interesting. I'm sorry that this is a third video on the same topic, but there it is. Might as well get it out of the way so that I can finally basically close this machine up for good, or until the next time. But I did want to demonstrate this because Candle thought it important, since the facility for VGA is built into the adapter board. He felt it was important that it got demonstrated, and now it has been. Thank you for all your support and your patience, of course, over the holiday period. It took me a real long time to get back into gear after the new year, and it's just been one mishap after another. I might actually make another short video about that, actually, to do with couriers and postal services and stuff. I had absolutely no luck whatsoever with anything that happened in the early part of December. But never mind, that's another story.
Yeah, I mean, first of all, I do apologise for what's happened there. I am sorry.
Thank you, of course, to all my viewers, all my patrons, including new patrons. I think we've had one over Christmas. Your name will be on the screen. Sincere thanks to you all, and in the next video I'll be back on a completely different subject. I don't quite know what it's going to be yet. I need to get this firmware released, so there's lots to do as soon as I've finished editing this one. So yes, thank you very much, and that's all for now, and I will see you in the next video, so bye bye for now.